Okay, so today we talk about series and infinity. Oh no, sorry. Today I'm going to talk about sequence and infinity series. So what's sequence? For example, we have a sequence here, 1, 2, 3, 4, something like that. And we can write it down like this. And what is infinity series? So infinity series usually look like there's a sigma in front of it, which means dimension, the sum of. So sigma from n equals to 1 to infinity of, whatever. Let's put an here. So you can see these two actually looks very similar. How to say that? Because as n equals to 1, it will be summation 1 equals to a1, and summation 2 equals to a1 plus a2, and summation 3 like from 1 to 2 to 3. Three categories are together, which you see here. S1, S2, S4, whatever. It would be like a sequence as well, like S1, S2, S3, something like that. So it could be look like, I want to say the series, it could be look like sequence as well, or it not look like some type of sequence. You can look at it that way. So in this chapter, what is very important about the infinity series? So what is important? Summation n equals to 1 to infinity of an. We want to know if this will be convergent or it will be divergent. How to know that? It is actually very easy and very direct. If the value you add is approaches to 0, so at the end it will approach some number very closely. So your infinity series will be convergent. But if the value you add is going to be bigger and bigger, then we don't know what it will be at the end, what's the value of it. So it will be divergent, like infinity. So how to know that? We use limit as n approaches to infinity, an. If this value is equals to 0, then what does that mean? That means the value you add will eventually very approaches to 0, so it will come to a number. Let's draw a picture here. So here you have your S1, which is A1, okay? So here you have S2, which is A1 plus A2. Here you have S3, which is A1 plus A2 plus A3. Here you have S4, which is A1 plus A2 plus A3 plus A4, so forth and so on. So if it's going to be like decreasing, let me draw. This will be more clear. Let's say it finally approaches to this value. Here you can see the distance will be your A2. Here will be your A3, A4, something like that. It's going to be, the distance going to be smaller and smaller, right? So that means as the n approaches to infinity, your an will be eventually 0. You can use this way to detect. But everything has exception. For example, the harmonic series. So what is harmonic series? Let's take a very signature example here. Sigma. Okay, sigma n equals 1 to infinity 1 over n. So this, as you can see here, if we use the limit as n approaches to infinity 1 over n, actually it's going to be 0 as n goes to the infinity because it is in the denominator. So the value is going to be very, very big, like very big. So if this certain value, although how small it is going to be divided by very, very, very a lot of portion, then it will be 0 because you divided it so many portions and the amount will be small and eventually it will be 0 as it approaches to infinity in the denominator. Right? So we thought this will be convergent, but it is not. It is divergent. Why? Okay, there are two ways to testify, and I will show two ways. So first, you can take observation, like direct observation. You put in a number and you observe, oh my god, the number is going to be bigger and bigger, so it's going to be divergent. Or you can use integral test to see what's the value. Let's see. So summation n equals to 1 to infinity 1 over n. Let's use the integral test. So the integral test, we can pretend it to be okay? You know why we need to pretend? Because usually in the series, it's actually dot, 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 dot. It's not like integral, which is smooth. And then we added them. And they're very, very small between each other, the distance. But, n need to be n, so which will be like dot, dot. So value will be this, which is different, that's why. Okay, so let's pretend these equations, sigma n equals to 1 to infinity 1 over n is similar to integral 1 to the infinity of 1 over n with not n, with is x. Usually we wrote s, so we don't make confusion. Okay, so x with respect to x. So this is very easy to integral. So this will be ln x, because we know the derivative of ln x will be 1 over x. So here, because here's the improper integral, I need to put limit in front of it as x approaches to infinite, not x, sorry. Actually, I need to take several steps back. So this will be limit b approaches to infinity. Why we put b, the letter b? Because usually you put a at the bottom and b on the top. But you can also put different later. I don't know if you kind of understand what you are writing. Okay, so integral 1 to b of 1 over x with respect to x, which will be limit as b approaches to infinity. 1 over, no, not over x. It will be ln x. And then from 1 to b, which will be limit as b approaches to infinity, ln b minus ln 1. And we all know ln 1 is 0, right? Because every number, if its power is 0, then it will be 1. No, sorry, it will be 0. Okay, so as b approaches to infinity, we all know this value is going to be infinity. Why? Because here's ln. Although it grows very, very slow, but it's still divergent. So here is infinity, and here is 0. So of course 0. And there will be, so the answer is actually divergent. Surprisingly. Okay, this is the first way. And the second one you can use, okay, let me write the number down. Second one you can use putting a number to observe. So this series, sigma n equals to 1 to infinity of 1 over n, will be look like 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6, so forth and so on. So let's start from the second one, which is 1 over 2. And we observe here as well. So as you can see, 1 over 2 equals to 4 over 2, which 3 here is 1 over 3 is bigger than 4 over 1. And 2 over 4 is actually equal to 1 over 4 plus 1 over 4. So it's going to be bigger and bigger and bigger, which make the infinity series to be divergent.